A moon is a natural satellite of a planet. So if you think about what a satellite is, it's something that is in orbit around a body in space. We put around a lot of satellites around space. Some of our satellites, like the Hubble Space Telescope, are out there looking outward, right, to observe things that are farther away. Other ones, we have them pointed back towards us, like the ones that we use for our GPS coordinates. But the moon is just like that. It's just a satellite as well. The difference between it is that it is also in orbit around the Earth, but it's natural, right? It's not man made. We didn't make it. It was there since humans were here. And we've pretty much always looked up at the moon and wondered what was going on there. Was it another planet? Did it have life there? Like was it just like our own planet? All these questions we did not know about. And we're still learning a lot about the moon, but we do know a lot more about it now. We know pretty much how it formed. And as you can see with this footprint here, it is the only celestial body that humans have traveled to in space. It's still probably one of the most remarkable achievements that humankind has ever, achieved. Because it's something that probably every single person that has ever lived that was able to see and looked up at the night sky has seen the moon and wondered what was going on. And, some people have been there. And now it's funny because that's ancient history. We haven't been anywhere since. But not all moons are like our own, right? Our own moon is a pretty dead, barren wasteland. There's nothing going on there. Other moons are pretty exciting. If you look at some of the other ones, for example, some of the moons of, let's say, Jupiter or Saturn, some of these have underwater oceans, they'll have volcanoes, they'll have all sorts of interesting things going on there. And it's possible that in our search for extraterrestrial life or aliens, let's say, really I'm talking about just any kind of life, not like smart aliens or anything, but for our search for extraterrestrial life, going to want some of these moons might be a better place than going to the actual planets that they orbit around, right? So if you go to Jupiter, for example, it's a gas giant. There's nothing that you can do. There's not going to be life that we can interact with because we would sink right through the outskirts of Jupiter and just go right into its core, which would be a horrible, deadly experience. But if we went to one of its moons, like Europa, let's say, it's possible that underneath its thick sheet of ice that there's an underwater ocean there, underground ocean, that there could be life there. There could be plants there. We have no idea, right? We might know one day, but as of right now, we do not know. So it's just exciting to think of all that. Speaking of Jupiter, if you look here, this is what Jupiter would look in the night sky if it was as close as the moon. Right? So a lot bigger, obviously, in our night sky. So that would be sort of similar to also, that would be the equivalent of if we were on one of Jupiter's moons and we were looking out, this is what it would look like to always see Jupiter in the sky like that, which would just be absolutely incredible, I'm sure. Over here, this is if Earth had rings like Saturn. So what's cool about this is depending on where you are in the world, right? So Saturn has these gigantic, amazing rings, but depending on where you are on Saturn or if it was around Earth, this is what it would look like from your perspective. So if you're at the equator, right, it just looks like a thin, bright line that goes around. Why? Because you're on the same plane. Like you're looking at it straight. You don't get to see the long view of it because you're looking straight at it. So it just looks like a line to you. But if you have a little bit of perspective, like over here, this is from Polynesia. I mean, look how gorgeous that would look right over there. If you're up all the way up in Alaska, so if you're like really far north, you barely see them, right? Over the horizon, you can't really see them. And then down here from Washington, D.C., that's what it would look like from there. So that would be pretty cool. If you look here, this is a view of what the United States would look like compared to our moon, right? So the moon is a lot smaller, obviously, and the United States could basically only fit on one side of it. So this is a great video that talks about what is a moon and how do we classify moons and what a lot of moons wind up doing. That is pretty interesting. So the moon and the sun are both responsible, both together, for the tides. Now there are two different tides. I'd like for you to draw a diagram that shows this. Okay, so this is known as spring tide. Now in spring tide, this is the strongest tide. Notice how they're all lined up together. You have the moon here, and the sun there, they're both pulling together in the same way. So because of that, you have the highest high tides and the highest low tides. So hopefully you know that every single day there are two high tides and two low tides. And it's like about every 6 hours it changes, right, from one to the next. So you now they can either be really like in generally low is always higher than obviously high tide. So the water will go recede out, it will go out more, or it will come in more, and that's during high tide. But sometimes a high tide in one part of the month is more intense than a high tide in another part of the month, and that's because of as the moon orbits around the sun and it has an orbital period of about 28 days, let's say about a month, it produces different effects on the tides. So when it's lined up in a row like this, or on the complete opposite side over there during the full moon or the new moon, this is known as spring tide, the strongest tides. Whereas if it's over here, if it forms like a right angle there, like a triangle, either down here, the third quarter moon or the first quarter moon, as it pulls in this direction, the moon, because the moon pulls a lot stronger than the sun does. So as it pulls here, it pulls away against the way that the sun pulls. So because of that, it's weaker tides. So spring tide is strong. Think spring is similar to strong, right? Spring and strong. And neap, EA in the middle, is a lot like weak. So those are the weak tides that come in. This is a video of our moon's formation a really long time ago. So it doesn't show the initial impact that caused our moon there, but you could see that afterwards it was a big ball of lava just like ours. It cooled down and then it was pelted by lots of asteroids and meteors, and then it cooled down again, and you could see how it has all of those volcanic areas right there that were, and then it gets pockmarked by all of these asteroids that hit it over and over and over again until we see all those craters in there. And then finally we have what it is today.